In this episode, we take the networking map you already started building and bring it closer to the kinds of traffic decisions that security teams make every day. Many beginners hear the words firewall, port, and application so often that the terms start to blur together, even though each one points to a different part of how network communication can be controlled. A firewall is not just a box sitting somewhere in the path. A port is not just a number in a rule, and an application is not just a program a user clicks on. All three can act as control points, which means they give an organization places where traffic can be allowed, limited, watched, or stopped based on policy and risk. That matters because most network traffic is not good or bad by nature. It becomes acceptable or unacceptable depending on where it is going, why it is going there, what service is involved, and whether that flow matches a legitimate business need. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. A good starting point is to understand what a network control point really is. It is any place in the flow of communication where a decision can be made about whether traffic should continue, be redirected, be inspected more closely, or be blocked. A firewall is one of the most familiar examples because it stands between parts of a network and applies rules about what is permitted to cross that boundary. Sometimes that boundary is between an internal network and the internet. Sometimes it is between different internal departments, and sometimes it sits on a single device protecting that device from unwanted connections. The important idea is not the shape of the firewall or where the hardware sits. The important idea is that it acts as a policy enforcement point, which means it turns security decisions into actual traffic outcomes. Once you see a firewall that way, it becomes easier to understand why ports and applications matter too, because they help define what kind of traffic is being evaluated at that decision point. A firewall works by examining parts of a network conversation and comparing them to rules that reflect what the organization wants to allow or deny. At a high level, those rules may look at where the traffic came from, where it is going, what kind of transport it is using, what port is involved, whether it belongs to an existing conversation, and sometimes what application appears to be generating it. This is why a firewall should not be imagined as a magical wall that simply keeps bad traffic out and lets good traffic in. It is much closer to a traffic control system following instructions about what kinds of movement are acceptable between two places. If the rules are broad and careless, the firewall may allow too much. If the rules are overly restrictive or poorly designed, legitimate work may be interrupted. The real value comes from placing control at meaningful boundaries and making sure the decision logic matches business need, data sensitivity, and the organization's willingness to accept risk. Ports are one of the pieces of information that help give those decisions structure. A port is a logical number associated with a service or process at the transport layer, not a physical hole on the side of a computer or switch. This is one of the first beginner misconceptions to clear up because the word port sounds physical even though the concept is mostly about directing traffic to the right destination process on a system. When traffic reaches a device, the port helps indicate which service or application should receive it, at least from the network's perspective. This is closely tied to the Transmission Control Protocol, TCP, and the User Datagram Protocol, UDP, because both use ports as part of how transport communication is organized. A firewall can look at those port numbers to help decide whether traffic appears to match an allowed service, which is why port-based rules are so common in network policy. The port gives the control point a clue about intended purpose, even though that clue is not always the whole story. It helps to think of a port as similar to an extension number inside a large office building. The building's street address helps traffic reach the right location at a broad level, but the extension helps direct the communication to a particular person or function once it gets there. In networking, the IP address helps the traffic reach the right device, while the port helps it reach the right service or process on that device. That is why certain services are commonly associated with certain ports, such as web traffic, mail flow, remote management, or name lookups. From a firewall perspective, this gives policy makers a way to say that some kinds of service access are allowed between certain systems and others are not. The danger comes when people assume the port number alone proves the traffic is safe or proves the service is legitimate. A port suggests intended function, but it does not guarantee that the activity using that port is trustworthy, properly configured, or appropriate for that particular path. This leads to an important security lesson that many beginners need early. An open port is not automatically a disaster, but it is a point of exposure that deserves a reason to exist. If a service is listening on a port and the firewall allows traffic to reach it, then that service becomes part of the environment's reachable attack surface. That does not mean it is vulnerable by definition, but it does mean someone has a path to attempt communication with it. A closed or blocked port reduces reachability, which is often good, but that does not solve every security problem either, because risky traffic might still flow through other allowed channels. The best way to interpret a port is as a controlled doorway tied to a service, not as a label of good or bad by itself. Security improves when organizations know which doors must remain open, why they are open, who should be able to approach them, and what kind of service is waiting behind them. That is the kind of thinking that turns port awareness into useful control thinking rather than simple memorization. Applications add another layer of meaning because users and businesses do not really care about ports for their own sake. They care about activities such as browsing internal sites, using collaboration tools, connecting to databases, transferring files, or accessing cloud services. A firewall that looks only at addresses and ports may understand part of the traffic pattern, but an application-aware control point may understand more about what kind of activity the traffic actually represents. This matters because modern traffic does not always fit neatly into one simple assumption where one port always means one clearly understood business purpose. Many very different applications can make use of common network paths, especially when they are designed to blend into ordinary web communication. That means a firewall may need to understand not only that traffic is reaching a common port, but also whether the application behavior on that port matches the organization's policy. The application perspective helps security teams move from simply allowing a path to allowing a purpose, which is a much richer and often safer way to think about control. Once you connect firewalls, ports, and applications, the control picture becomes much more realistic. A firewall rule is often strongest when it does not rely on only one piece of information, but instead combines several. It might consider the source network, the destination system, the transport type, the relevant port, the direction of the traffic, and the application or service involved. In some environments, it may also consider who initiated the session, what time the request occurred, or whether the device appears trusted enough to use that path. This layered decision-making matters because real risk rarely hides in one isolated field. A connection that is appropriate from one internal system to a business application server may be completely inappropriate from a guest device, a contractor workstation, or an unrelated department. The more precisely the control point can connect traffic to business purpose, the less likely the organization is to rely on broad access that feels convenient but creates unnecessary exposure across the network. Another beginner misunderstanding is the idea that firewalls only matter at the outer edge of an organization where traffic enters from the internet. That external boundary is important, but many meaningful control points exist inside the environment as well. Internal firewalls and similar controls can separate departments, data zones, development environments, management networks, and highly sensitive systems from ordinary user traffic. This is where ports and applications become especially useful because the organization is no longer just deciding whether outsiders may enter. It is deciding which internal systems may speak to which other internal systems, for what reasons, and under what conditions. A payroll server does not need the same network exposure as a public website, and a user workstation should not necessarily be able to reach every application server, management interface, or database path inside the company. Internal control points support segmentation by turning the network into smaller trust areas rather than one big open space where any allowed system can talk freely to every other system. State awareness is another concept that helps make firewall decisions smarter. Early or simpler filtering ideas may look at traffic in a more isolated way, evaluating one packet at a time with limited understanding of whether that traffic belongs to a legitimate ongoing conversation. A more stateful approach tracks the condition of a connection so the firewall can better understand whether the traffic is part of a valid session that was initiated in an allowed way. This matters because network conversations are not just random bursts of unrelated data. They often involve request and response patterns, return traffic, and ongoing exchanges that make more sense when viewed as a whole. For beginners, this helps explain why firewall control is not merely about blocking a list of bad things. It is about managing communication flows in context. A control point that recognizes whether traffic is starting a conversation, continuing one, or trying to behave in an unexpected way can make more intelligent decisions and reduce both needless blocking and careless exposure. A practical example brings these ideas together well. Imagine a user opening an internal human resources application from a company laptop. The firewall between the user network and the application zone may allow traffic only from managed corporate devices, only to the application servers that host that service, only on the ports associated with that application path, and only during approved communication patterns. That same firewall may block direct workstation access to the database behind the application, even if the application itself can talk to that database through a tightly limited rule. In this scenario, the firewall is the control point applying policy. The ports are part of how the traffic is identified and directed, and the application context helps explain why one path is allowed while another is denied. The important lesson is that security is not just about whether traffic exists. It is about whether the right traffic is moving between the right systems for the right purpose, while unnecessary paths are kept closed. Several common misconceptions become easier to correct once this picture is clear. One misconception is that a firewall alone makes a network secure, when in reality it is only one control among many and depends heavily on sound rules, visibility, and supporting practices. Another is that a port number tells you everything worth knowing about a communication, when in fact the same commonly used port may carry many different kinds of activity with very different risk implications. A third is that if traffic is encrypted, the firewall no longer matters, even though encrypted traffic still moves through control points that must decide whether the path itself should exist and whether the destination and purpose make sense. Some beginners also assume applications belong only to users and screens, but from a network perspective, applications create traffic patterns that can and should be controlled. Security improves when these ideas are not treated as separate technical trivia. They become much more useful when understood as connected elements in the same decision process. Attackers also think in terms of control points, even if they do not use the same teaching language. They look for exposed services, weakly restricted paths, overly broad rules, common ports used for purposes nobody is watching closely, and internal segments that allow too much movement once an initial foothold is gained. That is why interpreting firewalls, ports, and applications clearly is not just an academic exercise. It directly supports defensive judgment. If a service is reachable from places it does not need to be reachable from, or if a common application path is trusted too broadly, those control points become opportunities for abuse. On the other hand, when traffic paths are narrow, well understood, and tied tightly to legitimate business functions, it becomes much harder for an attacker to move casually through the environment. The goal is not to block all traffic. The goal is to make every allowed flow earn its place by matching a specific need, a defined path, and a controlled exposure. As you build your security thinking, one of the most useful habits is to stop asking only whether a connection is technically possible and start asking whether it should exist at all. When you see a firewall rule, a port allowance, or an application path, think about what business function it supports, what systems it connects, who can initiate it, and what might happen if the source system were compromised. That style of thinking moves you away from memorizing rule syntax and toward reasoning about control design. It also connects directly to least privilege, because the safest network exposure is not the broadest one that still works. It is the narrowest one that still supports legitimate operations. Firewalls, ports, and applications all become easier to interpret when you treat them as parts of a controlled conversation rather than as isolated technical settings. That is how beginners start turning networking knowledge into actual security judgment that can be applied across many different environments. By the end of this discussion, the main point should feel much clearer and more practical. Firewalls are policy enforcement points that decide whether traffic may cross a boundary. Ports are logical transport destinations that help indicate which service or process traffic is trying to reach. Applications represent the real business activities and software behaviors that give the traffic meaning. When you interpret all three as network control points, you stop seeing them as disconnected vocabulary and start seeing them as places where security policy meets real communication flow. That perspective helps explain why some paths should be allowed, why others should be tightly restricted, and why common traffic still needs careful thought even when it looks ordinary. Strong network security is not built by admiring the firewall, memorizing port numbers, or trusting applications automatically. It is built by understanding how each of those control points contributes to deciding what should move, where it should move, and why that movement deserves to exist in the first place.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.